Hello, welcome back. Today we're talking about volume of cones. Most of us are familiar with cones because we usually eat ice cream in one. So a cone has a circular base, and you'll notice that the sides, the lateral sides, they come up to a point that is directly at a right angle to the center of the base, and this is your height. The radius would be from the center of the circle to the outside edge. Sometimes they're shown with a diameter. So the volume formula for a cone is 1/3 the area of the base times the height of the cone, or you can write it as 1/3 pi r squared times height. So I found this example, and this was done by a teacher in another district, and he constructed a cylinder with popcorn and some cones. And so just take a look at this. It was shared by Mr. Mike Bubbles, and he does the experiment with the popcorn, and I wanted you to see that.
Here I have this cylinder filled with popcorn kernels, and it's clear, so it's difficult to see, but I have a cone right next to it. And I tried to make this so the height of the cone was exactly the same as the height of the cylinder. And I also tried to make it so the size of this circle on the top of the cone is the exact same size of the circle here on the cylinder. So the first question I have is, which one is bigger? Which one holds more volume? And so to do that, we are going to begin by pouring the popcorn kernels from the cylinder into the cone to see if we can completely fill the cone. So let's go ahead and begin filling that and see what we get. And it looks like now we have completely filled the cone, and there is a lot of popcorn left in the cylinder. So it's not a surprise then that the cylinder has a greater volume than the cone. And remember, this is true when the circle is the same size as the circle on the cylinder, and the height of the cone is the same as the height of the cylinder. Next, we've got this one filled up, but the next question is, well, how much bigger is the volume of the cylinder than the volume of the cone? And we can keep this cone right over here, but let's bring in a second cone, and let's start to fill this one. Alright, it looks like now we have completely filled a second cone, and there is still popcorn left in the cylinder. Let's bring over a third cone. Let's fill up this one. Now filled the third cone. Let's bring all those cones over here next to the cylinder. We have filled up 3 cones, and now this cylinder is completely empty. So it's kind of interesting to me, kind of a coincidence, that the volume of this cylinder will fill exactly 3 cones, not 2.5, not 4.5, not 5.5. Exactly 3 cones can be filled from that one cylinder. So now the next question is, what are we going to do about our formula? So, if we are looking at our formula for the volume of a cylinder,
Okay, so you were able to see that they took all the popcorn seeds from the cylinder and they filled 3 cones. So that means that the volume of this cylinder was divided into 3 cones. So if I know that the volume of a cylinder is the area of the base times the height of the cylinder, I can take 1/3 of it, and that's going to equal my cone. Okay, so that's how we got our formula. So in the Explore activity, we saw that the volume of a cone is 1/3 the volume of the cylinder with the same base and the same height. So let's find the volume of this cone. So we have a cone that has a circular base with a radius of 2. So there's my radius. And then it has, from the point directly down to the center of the circle, it is showing a height of 8. So I'm going to take and use 3.14 for pi, and any answer that is decimal, we're going to make sure it's rounded to the nearest tenth. So we're going to take 1/3 pi times my radius squared, so that's 2 squared, times my height of my cone, which is 8. So I'm going to have 3.14 times 4 times 8. And when I multiplied that, I got 100.48. And then I'm going to multiply it by 1/3. Remember, when you're multiplying by 1/3, that's the same as dividing by 3. So I'm going to take that and I'm going to divide it by 3. And I'm going to get 33.49. And because it's 33.49, if I round to the nearest tenth, the 9 tells 4 to go up. And so that's where we get our 33.5 cubic inches. Let's take a look at example B. This one is giving us a diameter instead of a radius, but we can get the radius because we know the diameter is twice the length and radius is half, so our radius is going to be 4. So we're going to take our pi, or 3.14, times 4 squared times 9, and we're going to divide that all by 3, and we're going to get 150 and 7/10, and that's cubic feet. Okay, so your turn, number 4. I would like for you to work out number 4, identify all the parts. So we need the radius and we need the height of the cone, and then I need for you to work it out, rounding your answers to the nearest tenth and using 3.14 for pi. Because we had a diameter of 15, we need to have a radius of 7.5. We know that the height is 16. So we take 3.14 times 7.5 squared times 16, divide the whole thing by 3, and we get 942 centimeters cubed. Find the volume of this cone. You should have identified that the radius is 2, the height of the cone is 3, and when you took pi times radius squared times your height, and divide that by 3, you get 12.56. Because we rounded to the nearest tenth, we get 12 6/10 cubic feet. Find the volume of the cone for number 8. Find it in nearest tenth if possible, and use 3.14 for pi. Okay, so you should have identified that the radius is 7, the height is 8, and that when you round it to the nearest tenth, you should have had 410 3/10 millimeters cubed. Okay, use this time to find the volume of number 9. If the radius is 2 and the height is 6, your answer would have been 25.1 cubic inches when it's rounded to the nearest tenth. For example 2, it says, for her photography project, Karen built a clay model of the volcano in the shape of a cone. Her model has a diameter of 12 inches and a height of 8 inches. Find the volume of clay in her model to the nearest tenth using 3.14 for pi. So it's telling me that it has a diameter of 12 and a height of 8. So if it has a diameter, my radius is going to be half of that, which is 6. And we know that the height is 8. Plug that into our formula. We have 1/3 of 3.14 times 6 squared times 8, and we get 301 and 44 hundredths rounding to the nearest tenth, we get 301 4/10 cubic inches. For the your turn number 6, says the cone of the volcano Petrusian in Mexico has a height of 410 meters and a diameter of 424 meters. Approximate the volume of the cone. Identify your radius, identify the height of your cone, and then find the approximate volume of this volcano. Your answer should have been 19,286,968 and 5/10 cubic meters. Okay, a snack bar sells popcorn in cone-shaped containers. One container has a diameter of 8 inches and a height of 10 inches. How many cubic inches of popcorn does the container hold? You should have found that the radius is 4, the height is 10, and when you do 3.14 times 4 squared times 10 and divide the whole thing by 3, then you get 167 and 5/10 cubic inches. Solve number 14 and come back for your answer. You should have found that the radius is 150, the height of the cone or the volcano is 150, and when you take the pi times the radius squared times the height of the cone, divide the whole thing by 3, you get 3,532,500 cubic meters. If you have any questions on how to work finding the volume of cones, please make sure that you see your teacher.